And in the last video, we proved this theorem that the opposite angle of a cyclic quadrilateral has supplementary. And we also proved that the exterior angle of a cyclic quadrilateral is equal to the its interior opposite angle. We're going to be using these two theorems to solve problems now in this video. Now, the first question we're going to be solving is the one you are having on the screen right now. Our aim is to find this angle A and angle B. And as you can see, you are going to use the two theorems that we just proved now to solve the problem. You can see that there's a relation between this angle 76 degree and angle B here. They are both opposite interior angle of a cyclic quadrilateral. Because this is a cyclic quadrilateral right now, you're having four-sided shape inside the circle. So that means 76 plus B will give us 180 degrees. From there, you can find our B to be equals to what? 180 minus what 76, that will give us 104 degrees. So the reason being that opposite angles in a cyclic. And also our angle A here, there's a relation between this angle A and angle 122 degrees here. This is an exterior angle of this cyclic quadrilateral. And exterior angle of the cyclic quadrilateral is equal to opposite interior angle. That means A here is equal to what? 122 degrees. And that's the solution to that first question. The second question we're talking about is the one you are seeing on the screen right now. And you're having O here to be the center of the circle. And that means that make this TQ a what? A diameter. A diameter. So we have to find angle X here. That's what we have to find in the question. But you can see that if this TQ is a diameter, that means this line, this chord that is joined to it, and this chord that is joined to it here, that means this angle here, total angle here is what? 90 degrees. We proved that an angle in a semicircle is at right angle. That means this is angle P here. Everything at P here is 90 degrees. And now we are having here TPQ. TPQ is 90 degrees, angle in a semicircle. If that should be the case now, in what you just proved now, you can see that this angle 132 degrees and this angle P here, this small one here, angle TPR, this angle here, there's a relation between those two angles, and this angle here, 132 degrees, and this angle here, raising opposite angles in a cyclic quadrilateral. Look at this line, 1, 2, 3, then 4. You can see now that's a cyclic quadrilateral. So that means this angle here, 132 degrees, and the angle P here, we had up to what? 180 degrees. That's what you're having here. Opposite angle in the cyclic quadrilateral. From there, you can find our angle TPR. So if you remove it from this one from 180, you have this angle here. And that way, you have 180 minus 132 will give us angle TPR. And the angle TPR will give us what? 48 degrees. If angle TPR is 48 degrees, but we know that total angle here, this angle here plus this angle here will give us 90 degrees. We have said that right from here. So if I know that this one is 48 and I can remove it from 48, or I can move 48 from 90 to get this remaining angle here. And that's what we're having here, that angle RPQ will give us 90 degrees minus 48. Because from here to here, total angle here is 90 degrees. Move this one from 90 will give us this angle. And that will give us what? 42 degrees. There's a relation between this angle here, angle RPQ, this angle here, and the angle X you are looking for. They're in the same what? The same segment. And angle in the same segment are what? Are equal. So that's why angle X is what? 42 degrees. 42 degrees. Then the next question here you are having on the screen right now, you are told that angle CE here, this line CE is a diameter. Line C is a diameter because of this is the center of the circle. So if line C is a diameter, that means this angle here, total angle here, is going to be what? 90 degrees. Reason angle in a what? In a semicircle. Because look at this line CD and line ED joined together. Then they meet at this point. So that means this angle here is a what? It's 90 degrees. Angle in a what? In a semicircle. Also, you can see that there's a relation between this angle here, this angle D here, and this angle 127. There's a relation between angle ADC. There's a relation between this angle ADC, this angle here, and this angle 127. Because this line 1, 2, 3, then 4. This is cyclic quadrilateral now. I know that opposite angle in a cyclic quadrilateral are supplementary because they will add up to 180 degrees. So if I know that this one is 127 degrees, I can find this angle here, this one here, that is angle ADC. So that if I remove from this one from 180, that will give us this angle. And that's what we're having here, angle ADC. Where is ADC? ADC. This angle here is equal to 180 minus 127, and that gives us 53 degrees. These are opposite angles in the cyclic quadrilateral. So I've told you that this angle E